I love it knowing one of you here because I could pick on one person, yeah?
Final limit.
That's for your horizontal asymptote because you want to consider what's happening when you get larger and larger values of x in the positive direction and also larger and larger values of x in the negative direction. Okay? Thinking about your hyperbola. So if you had y is 1 on x, okay? Right, where is the asymptote? Where are the asymptotes for our basic hyperbola?
Ah, 0.
X 0?
Oh, yeah.
Yeah, and y 0.
3x plus 2 cannot equal 0.
Excellent.
That's it.
So, 26. Alright, so up to number 3, asymptotes. Okay, so I would suggest you would write this each time working through this question until it comes second nature what you're doing, okay? In other words, vertical asymptotes. Where your function itself cannot equal 0, okay? So the whole function itself, remember we had our f of x equal to g of x over h of x, so we're really considering that bottom value. The polynomial on the bottom, where that cannot equal 0. Okay, so pardon me, x squared take away 3x plus 2 cannot equal 0. Right. So, we factorise that.
Plus or minus 2. X plus 2. Wait. X take away 2. X take away 1.
You're a bit of a shocker this morning, aren't we?
Yeah.
You know this. I can see that you know it. Okay, well at least we'll get all those silly mistakes out now before your exams, eh? We won't see any of them in the exam. So x cannot equal 1 and 2, so vertical asymptotes. Yep. Yes, so once you understand what you're doing, that work itself is actually really simple. Okay, it's just a process of getting the question started on that. Right, horizontal. Asymptotes, where, what's the condition for horizontal? How do we determine those? Freddie said about 2 times this morning. Yep. So we want to consider what's happening, very, very large values of x in the positive and also in the negative direction. Okay? So where the limit as x approaches plus or minus infinity of f of x. Okay? That's what we need to consider. Now, because we've already established that it's not even or odd, okay, we actually need to consider the limit, what's happening in both directions. Alright, so limit as x approaches, let's go positive side first, of 5x squared all over x squared take away 3x plus 2. Okay, do you remember what we do for our limits in extension?
You divide by the highest power.
Good, okay. Again, if you substitute infinity, you're going to have infinity over infinity, take away infinity, which is infinity, okay?
How?
Plus 2 is still infinity, alright?
Infinity
Because you don't know what infinity is.
is still infinity.
Yes,
That's crazy.
because you don't know what infinity is.
That's so weird.
Right, so limit as x approaches infinity of 5x squared over x squared all over x squared over x squared. Take away 3x over x squared plus 2 over x squared. Okay, so we still need to write the limit as x approaches infinity until we are substituting, and then you should always show the result in this case. So we usually do the substitution, that's what we did yesterday's lesson. Okay, we substitute the value for the limit approaches. However, I'm not going to substitute in 3 over infinity and 2 over infinity squared. So infinity squared is infinity. Okay, so what I am going to do is write the result. Okay, so I'm going to write the result of that. It's going to be 5 over 1. So what? Negative 3 over infinity.
0.
Okay, so take away 0. And what's 2 over infinity squared? 0. So 5 over 1, which is just 5. Alright, so I would consider a table of values to see which side of the curve, because it's not so obvious because you've got a negative 3 over infinity and then plus 2 over infinity squared. Okay, so I would actually suggest you approach it from the positive direction, because infinity squared is going to approach a large number much quicker than negative 3 over infinity. Okay, the process. Okay, so if I put 100 in both of those, okay, this is going to return a much smaller value. Okay, so I'm going to suggest that's going to be positive 1. So that, hang on. Let me process that and I'll come back to it. Right, so positive infinity, now look at negative. Okay, so we can go from this step here. Okay, we don't need to keep writing that same thing. Okay, so that far. Right, when you find the asymptote, that will give you information on your domain and range. Okay, that's the next thing you need to consider. Okay, your asymptotes will give you the values for your domain range. Okay, what's the domain?
Elements of the real number system such that x cannot equal 1, x cannot equal 2.
Good.
Now, why? How do we figure out the other one? One that was in between the two asymptotes going down.
That's a good point. Because we need our calculus skills that we haven't learned yet.
Go on.
Okay, so just to point out what's coming. Right, so calculus will allow us to determine the turning point here, where the part of the graph turned, okay, and then from that we'll be able to have a much more accurate representation of the range. Right, so in your text, I've had a quick look at it. You're going to get mainly the first couple of examples that we have, okay, and then I'm trying to think there was one of the harder, like one we're doing now. I can't remember. Okay, I'm just extending your thinking really. Okay, so we can won't have too many surprises when there's a question out there. Let's try and extend it as much as I can. I don't think without calculus we're not going to be able to. Without calculus, we're not going to be able to finish the graph. Okay.
Should we put it in any way?
Hey.
Are we going to put it in any way?
Using a table of values, we will consider it. Okay, so maybe I would put in 1.5, and then I'll do 1.25, 1.75, just to see what's happening. Okay, and then that will be the best we can do up to what we need to do. Okay. So from that, okay, so I'm just going to dot 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 because we're not going to be able to accurately answer that question. Right, so what we now should do is now consider a table of values. So we know there's the intercept at the origin. Okay. I know there are asymptotes at 1 and 2. Alright, so I'm going to consider what's happening, let's say 0.1, what's happening just to the right of the origin. 0.9, what's happening just before the asymptote. 1.1, what's happening on the negative side of the asymptote. 1.9 and 2.1. Okay, because I already know if I go in the negative direction, I'm going to get closer to the y value of 5, and also the same in the positive direction. If I consider what's happening on either side of the origin and the asymptotes, so I also need, let's go negative 1. Okay, what's happening on that side. Right, just to save us time, I'll just put it in here. Okay, so C of 0.1, so we've got 0.03, so put that in the table. Okay, well, I'll be back. Right, so I hope what I'm showing you is helping you how to use GeoGebra and what you can use it for. Right, so C of 0.9, so 36.82. So what that's telling me is from the origin, we go in the positive direction, okay, up to 0.1, and then as we get closer to the asymptote, we're getting higher, okay? So that part of the curve is going to go up higher and higher until it will approach the value of the asymptote but never reach it. Okay, so for example, C of 0.999. Okay, I'm getting some very big value of that value there. So 0.03, 36 point, and by default it's 2 decimal places. Okay, that's how it is by default. That's C of 1.1. What's happening on the right side of the asymptote? Okay, so that will tell me from way down, it's approaching the asymptote. 1.9. Okay, and as we get closer to the asymptote, it's still negative. If I go C of 1.5, halfway, negative 45. So I'm going from negative 67 up to negative 45 and then back down to negative 200. Okay, so we're having some sort of okay. Yeah, okay, but for the skills we've got, we won't be able to do that accurately until we've done calculus, okay? So calculus will allow us to determine that specific point where it turned, and then from that we can do a much more accurate representation of our graph. Yeah. Okay, and that will be done next term, actually, in mathematics and harder examples in extension. Right, now what's happening on the other side? So C of 2.1, 200.45. So way up on top of the asymptote, we're now coming back. Okay, so that's x equals 2 here. Alright, so x is 2.1, we're getting some really large value up there. Okay. And then there are no more asymptotes. I'm just going to probably try a couple more values. So C of, what was it, 2.1, let's say 3. 22.5, C of 4. Okay, so I'm going down, but still in the positive direction. Okay, and that's what turned my curve down. Up to the value where we're getting approaching infinity, we're getting closer and closer to that horizontal asymptote there. Okay. Now, C of -1. Okay, so 0.83. C of -2. Okay, so I'm just going back to the negative direction for your here. Okay, so -1. Okay, we're increasing, so -2, we're getting higher and higher. And then we know there's an asymptote there as we get to negative infinity. Okay, so we're approaching infinity by the underside now of that line there. Right, so with the information we have determined the intercept only at the origin. Okay, we have determined that it's not even or odd. We've also determined that there are 3 asymptotes on there. And then using a table of values, we've got some other features that we won't be able to do as accurately as what we want. Okay, but we can at least put that together into a general representation of what the graph looks like. Let's have a go graphing it. Okay, so start with your asymptotes and your intercepts. Right, so no, got 1. Remember the asymptotes are dotted line. 1 and 2. And y is 5. Okay, we know there's an intercept at the origin. That's the only one. Yep, so I know on either side of the origin it is positive, and because I know there are no other intercepts, I know it's going to turn. Okay, not going to cross, it's going to turn. Alright, so I know as I get closer and closer to x equals 1, I'm going to get a higher and higher value for y, which is these three figures represented. Okay, so yeah, something like that. And then between 1 and 2, I've got negative values for y, but we're starting with a lower number. Then we'll come up higher, it'll turn around and then go back down. Okay, so somewhere to show the general, this is what's happening. Okay, so until we do calculus, we won't be able to obtain more specific information about that. And then from x equals 2 onward, the curve's going to be in that portion of your graph. And then this one is going to increase until we're levelling out to the asymptote. Alright, so like I said, I'm extending it. Extending your understanding, so I'm covering all bases. Alright, so hopefully not too many surprises in your final exam. Right, any questions on that one? Right, the last one. Again, a bit more of a step up. Now, I said at the very start, have you got your notes? Okay, so I said these graphs are based on f of x is g of x over h of x. Alright, now I'm told you if the degree of g of x is greater than or equal to the degree of h of x, okay, so there may be a what's called an oblique asymptote, okay, an asymptote that has a slope. Okay, and this is what we covered more in extension 2, but there is a question in a past HSC paper or in your textbook that is on this concept, so at least I'll cover it. Now, I said degree of g of x is greater than or equal to the degree of h of x, which is this case here. Right, because the degree is 2 for both top and bottom, so that means that will match. I'm thinking it is not the equal component. Right, it's just when it's strictly greater than. Because when we do long division, we will get a remainder 1 degree less. Alright, let's try it. Right, let's have a look what it looks like. Okay, so y equals negative 3x take away 3 is the equation of the asymptote. haven't got a vertical one, x equals 1. Okay, so at least putting the idea out there, ready for your extension 2 concept, and thinking about more difficult applications of extension 1. Right, so if the degree of g of x is greater than the degree of h of x, then the quotient after doing long division will give the equation of the oblique asymptote. Alright, so D. So we got f of x equals negative 3x squared plus 2 all over x take away 1. Right, the degree of the numerator is greater than the degree of the denominator. So the first thing you will need to do is a long division. Alright, so x take away 1 is negative 3x squared plus 0x plus 2. Right. No? Alright. X, how many times does x go into negative 3x squared?
Negative 3x.
Sorry?
Negative 3x. And then that goes back.
Yep, so multiply that by the terms at the front. So negative 3x squared plus 3x. You do your subtraction at that point. The terms on the left side of the subtraction should go to 0.
Yep.
Alright, and then you have 0x take away a positive 3x. You have a negative 3x and bring down the second term. How many times does x go into negative 3x?
Oh, negative 3 times.
Yep. Negative 3, then negative 3 times x, negative 3x, and then negative 3 times negative 1, which is positive 6. Right, so really at this point we can stop, okay, because we ignore the remainder. The remainder doesn't give us any extra information, as far as I'm aware, okay, and that it gives you the equation of the oblique asymptote. Negative 3x, take away 3.
Whoa. What?
Okay.
Okay. That's weird.
But it works.
It works.
Mm-hmm. So, oblique asymptote. This the equation is y equals negative 3x take away 3. Right, and I probably should do that during the asymptote section. Right, so I might as well do it now with 3 asymptote. Okay, the vertical. I assure you any graphing questions in your exam will be more straightforward than what we're doing the last couple of questions, alright? I assure you. Right, what's the condition for the vertical asymptote to exist?
Oh, we just did it.
Yeah, we did.
Oh, look at it, it's moving. Oh, x cannot equal. Oh, sorry, x take away 1 cannot equal 0.
Good. Okay, so in other words, the function itself, where that cannot equal 0. Right, so x take away 1 cannot equal 0, the denominator. So x cannot equal 1, so vertical asymptote. Okay, horizontal. So how do we find the horizontal asymptote?
Divide
Yep, so in other words, taking the limit.
Taking the limit and
X approaches plus or minus infinity of the actual function. So okay. So equals -3 plus 0 over 0 take away 0.
cannot exist.
Excellent. Okay, which cannot equal that. Therefore, no horizontal asymptote. Now, again, in calculus, we will determine that coordinate and for the one down here as well. Okay, but for the skills that we've got now, the last thing we can do is test whether it's an even or odd function. Okay, and determine the intercepts. Okay, so let's go back to number 1, intercepts. So x-intercept.
Keep getting plus and minus.
Yeah, we need to get in that habit. Okay, and back here when we take the limit, I'm not going to bother taking the limit of x approaches negative infinity because I'm just going to get the same result. Okay, alright, x equals 0, so y is going to be -3 lots of 0 plus 2 over 0 take away 1. So 2 over -1, which is -2. Okay, which is that point there.
Isn't there?
Hey,
No, it's an asymptote.
so
I was going to say, isn't there one to the bottom one, but there's an asymptote there and it can't cross that
very
asymptote.
good.
Go.
Alright, so we determine those two x values there, and we determine that y value there. Alright? Right, so next we can determine whether it's an even or odd function. Okay, so f of x is -3x² plus 2 over x take away 1. F of negative x okay, the same as the original function.
No.
Okay, so it's not even. Okay, and now we need to do a negative f of x. So that's even if they match, and these are odd if they match.
Right, so if negative f of x equals f of negative x, it's odd.
Yep.
Okay.
Yep.
Those two. They both have a negative f. You get rid of that. No. I don't know what you that. No, you can't. Come on. It's not even valid. Everything. Alright. Continue.
So neither even or odd. Alright, let's do a quick sketch. I'm not going to consider the domain range because we're going to have restrictions on your domain, your range, sorry, that we're not able to accurately determine yet.
Yep.
Right, so we know we've got the oblique asymptote at negative 3x take away 3. So asymptote the dotted.
We have to do a table of values.
Should, okay, because we know the square root of 2 over 3 is going to be approximately 0.8, something like that. Okay, and we know we have a negative 2. Right. So those 3 points there will be enough, okay, in terms of drawing this section here. Like that, because I've got 3 points there already with the intercept.
Oh, that was horrible.
So we've got x equals 1, right? So I need to then consider what's happening in slower increasing intervals there. Okay, so D to 1.1. Okay, so negative 16.3. Okay, 1.2, 1.5, 2, okay, sort of numbers. Okay, to D of 1.2, negative 11.6. So from that, we're starting way down and close to the asymptote, going up. D of 1.5, still going up. D of 2, and now I'll go back down again. Okay, so somewhere between x equals 1.5 and 1.2, we're turning and going towards but never crossing the asymptote. So something like that.
That's right. That wasn't too hard.
No.
That wasn't.
Okay, so this is really more extension 2. Okay, and there's different techniques in extension 2 to how to graph this. Right, we'll talk about that when the time comes. But usually what were the skills that we have learned so far, but how we have to do it. You know, like I said, from memory, the questions are not in this sort of capacity. Okay, but if there is one that comes up in your text that I've seen or in a question that you're looking at,
I'll do
at
my
least
best.
And remembering your marks are coming from your working here more than the actual graph itself. Okay, so you can go through the process, find your intercept, find your even odd function in there, find your asymptote, get that information. From that, determine your domain range. And that will give you most of your marks. Okay, so the graph itself will only be worth 1 mark. So if you show a general representation of what it looks like, okay, you'll get your mark. So the graph itself is not worth 4 marks, okay, because I'm not looking for 4 different things on the graph itself, okay, because like I said, most marks are definitely coming from working out from there. Right, any question? That's probably a good natural stopping point. We'll finish by solving inequalities graphically. So already like your skills when you've done it in equation.
Yeah.
Okay, so now we're going to have a look at a different approach by doing graphs to solve inequalities. Have you had much more thought about your units we had this week?
I have. I'm yet to talk to Mr.
Papa, Solomon?
Sullivan about the scaling of aero skills.
Yep, that was certainly one. Did he use the water studies?
Yeah. So I'm not too sure about doing biology because it's quite, there's a lot of work to it.